So in this example here, you'll see that the question is the same question that you have watched in the pre-class assignment tutorial video for chapter 5. So I won't go through part A through D here. You can watch the pre-class assignment tutorial video on chapter 5. And basically just a recap of what we have in this question is that in this question, what we have the total revenue function is the 14Q, and then we have the total cost function, which is the 2Q plus 1800. So that's your total revenue, 14Q, total cost is 2Q plus 1800. And we know that at the break-even point, profit equals to 0. So profit equals to total revenue minus total cost, and that equals to 0 at the break-even point. So what that means is that at the break-even point, total revenue equals to total cost. So we equate those two equations, and then we solve for Q. And Q is 150, and that is your break-even point in units. So that's how many units that we need to sell to break even. And then we also calculated the break-even point as a percent of capacity by just taking the 150, the break-even point in unit, dividing that by the capacity of 2,500 to get to 6%. We also calculated the break-even point in sales dollar by multiplying the break-even point in unit, timesing by the selling price of $14 to get 2,100 in sales revenue. And that's your break-even point in sales dollar. And that was the pre-class assignment tutorial video. So we're going to go through the new material right now. Part E, draw a detailed break-even analysis graph. So when you're drawing the graph, I'm not looking for a detailed graph. I'm just looking for some of the key variables that you need to draw. So on the x-axis, you have your quantity. On the y-axis, you have your sales dollars. And then we have three graphs. Total revenue, the green line starts from the origins. Total cost function. And then we have the fixed cost function. So total cost and fixed cost has the same y-intercept, which is 1800 in this case. So what we need to do is draw these three graphs, and then we label the break-even points, which is the intersection between the total revenue, the green line, and the purple line, total cost function. So that is your break-even point. And then from the x-axis, we have the break-even point in units, which is the 150 that we found out. And then on the y-axis, we have the 2100. That is your break-even point in sales dollar. And that is all I'm asking for. Three graphs, total revenue, total cost, fixed cost, three graphs, and then the break-even point in units, and then break-even point in quantity. Part F, determine the break-even point in units if fixed cost decreased by $500 while variable cost per unit increased to $3.50 per unit. So what we're looking for here is break-even point in units. So we're looking for BEP in units in quantity. That's what we're looking for, break-even point in units. And what we have found out is that the fixed cost decreased by $500. So it decreased by $500. So fixed cost was $1,800 before. Now it decreased by $500. So now your fixed cost is $1,300. That is your new fixed cost. And we also found out that the variable cost per unit increased to $3.50 per unit. So your new variable cost per unit is $3.50. That is your new variable cost per unit. So those are the two changes that we have. Fixed cost changed to 1,300, and then variable cost is now 3.5. So once we understand these two changes, then now we're going to calculate the break-even point in units. And we know that at the break-even point in units, our profit equals to 0. So when profit equals to 0, then total revenue equals to total cost. So this is the condition that we have. Because profit equals to 0, then that means total revenue equals to total cost. Then we can substitute the equation. We know what total revenue is. Total revenue is 14Q. And in total cost, there are two parts. Fixed cost plus the variable cost per unit times Q. So fixed cost is 1,300. That's what we have calculated above. And we have the new variable cost per unit, which is 3.5. And we multiply that by Q, the quantity Q. Once we have the equation set up, we're going to solve for Q. And you're going to get the Q equals to approximately 124 units. And that's part F.